Hey guys, so this week we're going to actually start talking about the rules of exponents or the laws of exponents. Today we're going to work on multiplying like bases. These topics aren't really too hard, it's just when you combine them all together, it gets a little confusing and you really have to have your rules straight. So make sure you take notes and you're writing these examples down. So multiplying like bases, the rule for that is when you have powers with the same base, all you have to do is add the exponents. So I'm going to kind of show you why the rule is true and then write the rule in a general form. For this one, we have a to the fourth times a to the second. Notice how we're multiplying and our bases are the same. Remember, your bases are your bottom number, your exponents are your small number up in the right-hand corner. So we know a to the fourth is a multiplied by itself 4 times. We know a to the second is a multiplied by itself twice. So if you look here, how many a's do I have? Hopefully you said 6. So we get a to the 6th. Now if you notice, my rule says if they have the same base, you can add the exponents. If you add your exponents, what's 4 plus 2? 6. So that's where it comes from. Now the general form of this is a to the m times a to the n is equal to the a to the m plus n. So all that's saying is when you're multiplying, you're the same base, add the exponent. So if you look here, we're multiplying, we have the same base. So your base stays the same, add your exponents. What's 3 plus 2? 5. Here we're multiplying. Are our bases the same? Yes, so keep your base, add your exponents, and you get 10. Next one, we're multiplying. Are your bases the same? No, they are not, so you cannot use the rule. You just leave it how it is. Now this one, if you notice you're multiplying a bunch, do they all have the same base? Yes, they do. So you keep your base. 5 plus 6 is 11, plus 2 is 13. So your answer is b to the 13th. Now where you have multiplying, our bases are the same. So keep your base and do what to your exponents? Add them. We're multiplying. Are they like bases? No, they are not, so we cannot simplify. Sorry, that should be an arrow. So we leave it how it is. Next one, we are multiplying. We do have the same base, but we have one with an exponent and one without. This is just like when you were solving equations and you had an x but no number. When you have an x with no exponent, you assume there's a 1 there. You cannot forget that 1 or you are going to screw up a bunch of problems and you don't want to screw up easy problems. So now that you know that, keep your base, which is x, add your exponents. 1 plus 4 is 5. So now every problem you should ask yourself, do I need to put a 1? So looking at this problem, do I need to add 1s anywhere? Yes, I do right here because there's a x without an exponent. So this one's a little different because you have constants on the outside. Had I just had this, I don't know how to cover this up nicely, a 3 and a 5, you would just do 3 times 5. It's the same thing. So you're going to multiply your constants. 3 times 5 is 15. Your bases are the same, so keep it. Add your exponents and you get 6. Next one, you have 2 constants. So multiply. 4 times 6 is 24. Your bases are the same. Do you need to add any ones? Nope. So keep your base, add your exponents, and you get a 5. And then we have 2x times 8x to the 4th. Do I need to put ones anywhere? Hopefully you said yes. Your constants, what do? Multiply. Your bases are the same, so keep it. Add your exponent. All right, a couple more. Try some on your own, and then you're done for the day. So our next one, we're gonna have a squared b times a to the 0, b to the 3rd. So looking at this one, you have multiple variables. Even though there's no dot in the middle, they're still being multiplied because you know parentheses mean multiplication. So you just work with one variable at a time. Start with your a squared. In this expression, is there any other a? Yes, there's an a to the 0. So you keep your base and add your exponents. What's 2 plus 0? Hopefully you said 2. Now move to your next one. We have a b. We notice that b doesn't have an exponent, so what do we have to put there? A 1. Is there any other b in this expression? Yes, there is. So we have b. Add your b exponents. 1 plus 3 is 4. So your final expression is a squared b to the 4th. Say you had 2x to the 3rd y times 3x squared z. So again, you have constants. You always know constants work the same as they always do. Get that out of the way first. 2 times 3 is 6. Go to your next variable. I have x cubed. Is there any other x cubed, any other x in this problem? Yes, there is. So you're going to keep your base, add your exponents. 3 plus 2 is 5. Now my next thing we got is a y, just kidding. And I answered my next question. What do we have to write up here? A 1. Is there any other y in this expression? There is not, so you're just gonna drop it down. Don't write the 1 because it's not in the prettiest form if we write the 1. So now if you notice, not everything has a mark on it. We have this guy over here. We know when there's a base and no exponent, we gotta put a 1. Is there any other z to combine it with? There is not, so we drop it down. And that is our final expression. Again, don't put the 1 because it's not pretty when it has the 1. All right, next one. We got this 7y to the 5th x cubed z times negative 1y x to the 4th z to the 9th. So right off the bat, I'm going to ask, do I need to put ones anywhere? Let's just get this out of the way now. Hopefully you said we need to put a 1 on the z and a 1 on the y. Start with your constants. What do you do to your constants? If you had something that looked like this, you would know to multiply it. Same thing, 7 times negative 1 is negative 7. Go to your first variable. We have y to the 5th. Is there any other y? Yep. So keep your base, add your exponent. 5 plus 1 is 6. Move to your next. We have x to the 3rd. Is there any other x? Yep, x to the 4th. Keep your base, add your exponents. 3 plus 4 is 7. And next up, we have a z. Any other z's in the expression? Yep, right here. 1 plus 9 is 10. Not too shabby, right? All right, we are gonna do one more together. You're gonna try some on your own because I missed this one that I wrote. So we're gonna make it a little bit of a challenge one. We're gonna combine the rules from negative exponents and multiplying like bases. So say we had a to the negative 8th, b to the 2nd, a to the 2nd, b to the 6th. So say to yourself, do I need to put ones anywhere? Hopefully you said no, everything has an exponent. First one we got is a to the negative 8th. Is there anything that goes with that? We got a squared. So what is negative 8 plus 2? Hopefully you said negative 6. And then we have b squared. And what goes with that? B to the 6th. Keep your base, add your exponents. Now, one thing you're going to learn probably in a day or two is your expression is not simplified if there's a negative exponent in it. So looking at this, when we see a negative exponent, you know automatically you want to make your fraction. How do we make a negative exponent turn positive? We have to bring it to the opposite side of the board. That stays where it is. So that's your final answer. All right, you have these practice problems and you are donezo. First one, 5 to the 3rd times 5 to the 2nd. Number 2, x squared times x. Number 3, 2 to the 3rd times 3 to the 4th. Number 4, x to the 5th, y to the 7th times x to the 3rd, y to the 8th. Number 5, x, y to the 8th, z to the 2nd times x squared, y squared. Number 6, 3x to the 5th times 9x to the 10th. Number 7, 4x squared, y to the 5th, 16y cubed, x squared. Whoops, sorry, you can't really see that. And last but not least, how about, I don't know, 23x to the 4th, y to the 5th, z times x to the 3rd. All right, good luck and goodbye.